It was David Travis who first caught a glimpse of what the world could be like without global dimming. It happened in those chaotic days following the tragedy of 9/11. For 15 years, Travis had been studying the vapor trails, or contrails, left behind by high-flying aircraft. How big an effect the contrails were actually having. The only way to do that was to find a period of time when, although conditions were right for contrails to form, there were no flights. And of course, that never happened. Until September 2001. Then, for 3 days after the 11th, virtually all commercial aircraft in the US were grounded. It was an opportunity Travis could not afford to miss. He set about gathering temperature records from all over the USA. Travis was not looking just at temperature. That varies a lot from day to day anyway. Instead, he focused on something that normally only changes quite slowly: the temperature range. The difference between the highest temperature during the day and the lowest at night.
So here we see for the 3-day period preceding September 11th, a slightly negative value of temperature range with lots of contrails as normal. Then we have the sudden spike right here of the 3-day period. This reflects lack of clouds, lack of contrails on warmer days, cooler nights, exactly what we expected, but even larger than we expected. So what this indicates is that during this 3-day period, we had a sudden drop in global dimming contributed from airplanes.
During the grounding, the temperature range jumped by over 1 degree Celsius. If so much could happen in such a short time, removing just one form of pollution, then it suggests that the overall effect of global dimming on world temperatures could be huge.
The 9/11 study shows that if you remove a contributor to global dimming, jet contrails, just for a 3-day period, we see an immediate response at the surface of temperature. Do the same thing globally, we might see a large-scale increase in global warming.
This is the crux of the problem. While the greenhouse effect has been warming the planet, it now seems global dimming has been cooling it down. So the warming caused by carbon dioxide has been hidden from us by the cooling from air pollution. But that situation is now starting to change.
We're going to be in a situation, unless we act, where the cooling pollutant is dropping off while the warming pollutant is going up. CO2 will be going up and the particles will be dropping off, and that means we'll get an accelerated warming. We'll get a double whammy. We'll get reducing cooling and increased heating at the same time, and that's a problem for us.
And that's not all. Climatologists like Peter Cox have begun to worry that global dimming has led them to underestimate the true power of global warming. They fear that the Earth could be far more vulnerable to greenhouse gases than they had previously thought.
We've got two competing effects, really. That we've got the greenhouse effect, which has tended to warm up the climate. But then we've got this other effect that's much stronger than we thought, which is a cooling effect that comes from particles in the atmosphere. And they're competing with one another. And we know the climate's moved to a warmer state by about 0.6 of a degree over the last 100 years. So the whole thing's moved this way. If it turns out that the cooling is stronger than we thought, then the warming also is a lot stronger than we thought. And that means the climate's more sensitive to carbon dioxide than we originally thought. And it means our models may be undersensitive to carbon dioxide.
The models that everyone has been using to forecast climate change predict a maximum warming of 5 degrees by the end of the century. But Cox and his colleagues now fear those models may be wrong. Temperatures could rise twice as fast as they previously thought, with irreversible damage just 25 years away.
If we don't do anything, by about 2030, we could have a global warming of exceeding 2 degrees. And at that point, it's believed the Greenland ice sheet would start to melt in a way that you wouldn't be able to stop it. Once it started, it would melt. Take a long time to melt, but ultimately it would lead to a sea level rise of 7 or 8 meters.
Once the Greenland ice cap begins to melt, nothing will stop it. Many of the world's major cities will be living on borrowed time. Decade by decade, the risk of catastrophic flooding would increase inexorably. But unless action is taken, it won't stop there. Because after Greenland, the world's tropical rainforests will start to wither in the heat.
2040 could be 4 degrees warmer. The climate change could have led to a big drying, particularly in the Amazon basin. That would make the forest unsustainable. We'd expect the forest to catch fire, probably, turn into savanna, and maybe ultimately even desert if it gets really, really dry, as our model suggests.
And as the rainforest burnt away, it would release vast amounts of carbon dioxide into the atmosphere, driving global warming still further. Cox calculates that in just a century, the world could be 10 degrees hotter.